Okay, so this is number 3 on the free response. Some of these will be multiple choice on the real test. First of all, it says match each curve to the one of the following titrations. For each titration, write the full in molecular form that occurs as titrant is being added before the equivalence point. It really doesn't work out at B to write the full molecular equation, so you end up writing the net ionic for that one. So when we get to that one, don't be disturbed by that. Letter A, it says HBr in a beaker titrated with KOH. So if you think of this physically, there'd be a beaker and it would have some hydrobromic acid in it. And inside of there would be a pH probe, and then there would also be a burette that would be delivering some KOH to it. And so you drop the KOH in there. Obviously there'd be a spinner in here to mix it, and then we would have the pH increase as we go along because you're adding base to the acid. And so the reaction would be the acid plus the base, and then eventually it would make KBr, that salt, and some water. Now before the equivalence point, we would have lots more of this left, and this would just be getting used up, and we'd make lots of this as we go along until we get past the equivalence point. And to match this one, you'd look for something that has a really low pH to start with, because this is a strong acid and we're adding to it a strong base. Strong acids should start at a really low pH right down here, and they should end at a really high pH right up here. So that's why you pick the first one to match that, because strongs would start low and strong would end really high and have only one equivalence point right here in the middle where the moles of acid are equal to the moles of the base. Okay, and the next one, it says K2SO3 is in a beaker. So now inside your beaker you have some K pluses, which would do nothing in solution, because remember K pluses come from a strong base, and of course those would act neutral in solution, because if the cation or anion came from a strong, they would be neutral. And so if you look right here, K is in the B area right here. And then it also has some SO3 2-. And SO3 2-, this anion must have come from a weak acid, and therefore this is going to act as a conjugate base, or just get rid of the word conjugate and just say it's going to act basic. And so this is going to want to get protons from something, and you can see it's going to get protons from HCl. And so the best way to write this is in its ionic form and say, okay, there are 2 K pluses in there, and there's some SO3 2- in there. And then before we get to the first equivalence point right here, we're going to add some hydrogen ion to it and some chloride ion to it in the form of HCl. And remember, that's a strong electrolyte, so we break it up completely. And then over on the right-hand side, this is going to get protons, so we're going to get some HSO3-. And then we're going to still have some K pluses doing nothing, and we're going to have some Cl minuses doing nothing. And so these spectator ions actually just cancel out of the net ionic equation, and you can see that before the first equivalence point, we get these things reacting together to make this weak substance right here that has an affinity for protons, but could act a little bit more basic as well and gain a few more. So what titration curve would this be? Well, first of all, when you have your pH probe in there, since we said it would act basic, it would start pretty high. And then it says it requires 2 protons to complete a reaction, so we should have 2 equivalence points on this. And so the one that starts pretty high and has equivalence point 1 and equivalence point 2 would match this one, so this would be titration curve number 4. And then the second equation, after the first equivalence point, now we take some of this that has formed, HSO3-, and we still add more hydrochloric acid to it. And of course, this is still willing to take a proton, and so we make some H2SO3 right here. And the chloride ion just sits there and spectates once again. So that's our second equivalence point equation. Don't be too bent out of shape that it doesn't say net ionic equation, but that's the best way to show it, is that it gains a hydrogen and then gains another hydrogen as we go along. Letter C, HNO2 is a weak acid. Okay, so it's titrated with KOH, so we have to start at a little higher pH. So when you're matching this one up, it's got to be the one that starts right here. And then it's going to titrate with KOH.
Bless you.
So that's going to end up like really pretty high pH up here. So we start here at fairly high, and then we end up at like way up here. And I know the scale isn't perfect on here, because you'd guess this is like way up here, about like 6 or 7. But imagine that it's not quite to scale, and we end really high here, but we start a little higher here as well. So number 3 would be for this one. And the equation for this one would be the HNO2 reacting with the KOH to make water and KNO2. And then the last one is a strong acid and a strong base. And so the strong acid would be titrated into the strong base. And so it says the NaOH first is the thing in the beaker. And so we would have a high starting pH for that right here. And then we'd have a really low ending pH for that one. So that would be number 2 right here. And here's the equation of what happens to that one, making an inert salt right here, or one that has a pH of 7 that's neutral. All right, there is our number 3.